Okay, so we're looking at our first video on the revision for the test, and I'm hoping that I won't make any mistakes along the way. So this is discrete random variables, where we've got whole numbers and tables and things. So let's have a look at the first question. A coin is tossed twice. Let x be the number of heads obtained. Construct a probability distribution of x. Okay, so pause, and when you're ready, come back live. Okay, so we had to go. Okay, so we've got x, we're tossing it 2 times, so we've got 0 heads, 1 head, or 2 heads. And the probability that x equals x is a quarter, a half, and a quarter. You can do that with a tree diagram if you want to, or you could do it with combinations, but it's a quarter, a half, and a quarter. And note that the numbers have to add to a whole. Okay? If it doesn't add to 1, you are shot. You do not have a PDF. Okay, so let's look at the next question. Okay, so a bag contains 4 blues and 5 red balls. 2 balls are taken out with replacement. Let x be the number of red balls obtained. Find the probability distribution of this random variable. So it's a similar question, but the fractions won't be the same. So you might want to do combinations. You might want to do a tree diagram. So have a go, and when you're ready, come back live. Okay, you might have had a go by now. So if you want to do separate calculations, so we're looking at red balls. Okay, so red's the magic color. So, and we are taking how many balls out? 2 balls. So to get no red balls, so it's 2C0. Red is 5/9 to the power of 0. 4/9 squared, and then 1 red, 2C0, 5/9 to the 1, 4/9 to the 1, and then 2 red balls, 2C2, 5/9 squared, 4/9 to the 0. Okay, so I'm going to pause and just work out those fractions, so I'll come back in a sec. Okay, so we're back, and I've just worked out those numbers just on my calculator, and I had 16/81, 40/81, 25, and just to make sure, 56, 61, 81. So that adds up 81/81, which is 1. And so the question was find a probability distribution table. So x, 0, 1, 2, and probability that x equals x, 16/81, 40/81, 25/81. Okay, so let's move on to the next question. Okay, this next question, we've got to find the values of b, and then we do something with the values. Okay, so pause, and when you're ready, come back live. Okay, so we've got the numbers have to add up to 1, so 6b plus 0.4 equals 1, 6b equals 0.6, so b equals 0.1. So that's 0.3, that's 0.2, that's 0.1, and we had 0.4 already, so b is 0.1, and probability that x is greater than or equal to 3 is those 2 numbers, so it's those 2 numbers, so the answer is just 0.5. So be ready for one where you might have to solve an equation that's a bit harder than that, like a quadratic, but that's basically, you have to know that these numbers have to add to 1. Okay, copy, and when you're ready, come across. Okay, so for this next one, this is discrete. You've got the values here, 1, 2, 3, 4, 5. So it's discrete. Even though it looks like you've got something you might sketch, but we've got values to sub in. Okay, so we're going to find k such that it's a PDF. Okay, so, well, have a go. If you're not too sure, wait 5 seconds and then press play. It'll be there in a sec. Okay, and let's go. Okay, so x is 1, 2, 3, 4, 5, and probably that x equals x. So we're going to put 1 there, and 2, then 3, then 4. So the first one is going to be x over x plus 1, and then it will be 2x over x plus 1, 3x over x plus 1, 4x over x plus 1, 5x over x plus 1. Okay, so that's not too hard so far. What are we going to do with them? We're going to say that they equal 1. Okay, so So the common denominator is x plus 1, okay, and we've got x, 3x, 6x, 10x, 15x, so that equals 1, so 15x equals x plus 1 when you cross multiply, and take the x back, so we got 14x equals 1, so x equals 1 over 14. Okay, so we found it. Find k. Okay, I don't think there's any mistakes there, so let's move on. Okay, so this is our long question. A random variable x has the following distribution table, blah blah blah. Okay, so we have to verify that it's a PDF, and then find some EX will be easy, that'll be easy. That'll be hard because we've got to do EX squared, and then this will be easy from D. This will be easy once we've got D, and once we've got the numbers, that'll be easy. Actually, we don't even need to have any answers like that answer there. We've got the numbers in here, so that's going to be the easiest question on the board. Okay, so this will be a long one, so have a go. When you're ready, come back live. Okay, so the expected value of x will be multiplying the numbers. So we've got 0, so we've got 0.2 plus 0.6 plus 1.2, and so the answer is 2.0. So that's the expected value. So multiply the numbers and then add. Okay, so e2x, okay, so that's ex. And so to get e2x minus 1, we just double that number and subtract 1. So it's 2 times 2 minus 1. So that's 3.0. Now this next one's a bit harder. Var x, we've got to do ex squared minus ex all squared. So this is going to take us a bit of time. So we've got to go back and we've got to do ex squared. So 0 squared, okay, so the first number is 0, 1 squared will be 0.2, 2 squared is 4, 3 is 12, 3 squared is 9, 4 is 36. So 12, 1.4, so we get 5.0. So that's ex squared. So var x will be 5 minus that number, ex squared. So 5 minus 4 equals 1. So the variance is 1. Okay. Okay, so that's that one done. We've done that, and we've verify that's a PDF. Sorry, the numbers add to 1. So that was easy. Okay, var 2x. So let's go down. Var 2x. Now the formula is we just take that number and we square it, so it's just 4 times var x, which is 4 times 1, which is just 4. Okay, f is related to d, so f standard deviation equals the square root of the variance, which is the square root of 1, which is 1. And the last one we actually didn't need, so we got to find, go back up to the table. Okay, so we've got to look for the overlap between these two and then divide by x less than 3. So x is greater than 1 are those numbers, x is less than 3 are those numbers, so the overlap is 1, 2, 3. Okay, so just remember that. So x is greater than 1 is those numbers, x is less than 1 is all those numbers, and where they overlap is the intersection. So it's going to be, so this answer here is 0.9, and less than 3 is all the numbers, so the answer is just 0.9. Okay, right up. Hopefully you had a go at that and enjoyed it. There's one of those on the test. Come across the next slide. Okay, so from a pack of 52 cards, a card is drawn at random. A person is paid $8 if it's a king or a queen and $10 for an ace. Any other card the player loses, what must be charged for the game to be fair? So for fair, we need to get a nil, like net result 0. Okay. So we need to do a table and work out some probabilities. So when you're ready, have a go, and then come back live. Okay, so ace, king, queen will put together, and then jack to 2 will put together, as all those other cards. So there's a 1/13th chance of getting an ace, there's a 2/13 chance of getting a king or a queen, and there's a 10/13 chance of getting anything else. Okay, so they're the outcomes. Okay, so if you get a king or an ace, you get $8, get $10 for an ace, and we lose. Okay? Excuse me. Now, if it's a fair game, the result is going to be 0. So we've got, for a fair game, 10 times 1/13 plus 8 times 2/13 minus x times 10/13 equals 0 for a fair game. So let's just do it. So 10 over 13 plus, well, that should be 13, sorry. 16 over 13 minus 10x over 13 equals 0. So you can forget about the 13s. So we got 26 minus 10x equals 0. 10x equals 26. X equals 2.6. So what should be charged is $2.60 to play. Okay, so x equals 2.6 is a fair game, so the game has to be charged $2.60 to be fair. Okay, come across when you're ready. Next slide is the last one. Come on. Okay, consider the random variable that has a probability distribution as shown, blah, blah, blah. So we've got to find this answer here. Now, note that the answer is not going to be 95%, okay, because we don't have a normal curve. So what we have to do is we've got to find the mean and we've got to find the standard deviation, so we've got to do a few things, okay. It's not going to be quick. So, you should have a go first yourself. Okay. So you need to find the expected value and then EX squared and see how you go. Alright, back live. EX is 0.31 plus 0.72 plus 0.57 plus 0.20. And I'm going to get my calculator, which is in my pocket. Get my calculator out. 0.31 plus 0.72 plus 0.57 plus 0.2. So the expected value is 1.8. Now we find, so that's going to be the mean, okay, which is that symbol U upstairs. So we've got EX squared. Okay, so we're going to multiply. So the first one's 0 again, and then 0.31, and then 4 times 36 is 1.44. 9 times 19. I can't do that in my head. Should be able to, but I don't. That's not right. Got a wrong answer on my calculator. 1.71 and 16 fives are 80. So that's 0.8. So add those numbers up. We get 4.26. And so, EX squared minus EX all squared is 4.26 minus 1.8 squared. Now I need my calculator for that. .02, so that's the variance, and that is the standard deviation. So the standard deviation equals the square root of 1.02, square root 1.02 equals 1.009. Okay, so what we've got now, change colours, is this question is saying 1.8 minus 2 less than equal to x less than equal to 1 plus 1.8, sorry, plus 2. So that's a negative number, but the lowest number is 0. So that effectively means we've got 0. And 1.8 plus 2 is 3.8. Now, it has to be less than 3.8, so we can't use the 4. But because this number here was negative, we can use a 0. So it's going to be those numbers, okay? And by a fluke, okay, the answer is 95%. Okay, but it's nothing to do with the normal distribution. That's the way it came out. Okay, so it is 0.95, but it's not because it's a normal distribution. Okay, and that's the last slide. So I hope you got something out of that. And the next one will be continuous random variables.